Right, we are going to start Unit 4. It's all about triangle congruence. So 4.1, classifying triangles. This one's going to be pretty easy, and it's all stuff that you've really done before. So bear with us. We'll move through it pretty quickly, and then we'll move on. So first thing is when you classify triangles by angle measure, you can call them different words. So acute, equiangular, right, or obtuse. So most of these angle classifications you're familiar with. But when you put them in a triangle, they have just a little bit different definition based on the angles that you do already know. So let's go ahead and talk about acute. So in an acute triangle, all three angles are acute angles. And if you remember what acute means, it means less than 180. I'm sorry, less than 90 degrees. So they are going to be all less than 90 degrees, those angle measurements. So for equiangular, we're going to have all three angles are congruent. So all three angles are the same measurement, are congruent to each other. And if you do the math for this one, you can do 180 divided by 3, and you'll get that all of the angle measurements are 60 degrees for an equiangular triangle. All right, a right triangle is going to be a triangle that has one right angle. As you can see, it's noted by the box here. So that is a right triangle. And last but not least, an obtuse triangle is a triangle with one obtuse angle. So once again, none of these should be too crazy. They just are basically reflecting the angles that are inside the triangle. We can also classify triangles by side length. So we have equilateral, isosceles, or scalene. All right, so just like equiangular means equal angles, equilateral means equal sides. So lateral is another word for a side. So all three sides are going to be congruent in these triangles. So an isosceles triangle, by definition, says that we have at least two sides congruent. And you can see the tick marks here in the picture. So that's going to be an isosceles triangle. Note that an equilateral also fits that definition, right? At least two sides congruent means that all three sides could be congruent. But we always want to specify a triangle based on its most specific classification. So if you see a equilateral triangle, you'll always want to call it equilateral, not isosceles, unless the question states all the possible names for it. But typically, if all three sides are congruent, that's equilateral. And if you see only two sides congruent, that would be isosceles. And last but not least, if you have no sides congruent, that's going to be scalene. So if all the sides are different, so let's say this is 4, this is 7, and this is 10, that would be a scalene because none of the sides are congruent. All right, so then the question here is classify each triangle based on its angle measurements. Note, give two classifications for part C. So this time we're going on angle measures, so we're looking at one of the top row of answers. So either right, obtuse, equiangular, or acute. All right, so for this first one, feel free to pause the video if you want to give it a shot on your own first. But for this first one, we have a 45, 45, 90. So because it has at least one right angle, this is going to be a right triangle. Right triangle. All right, next one, part B. Once again, because we have one angle that's going to be obtuse, this is going to be an obtuse triangle. And part C, we have three angles that are all the same. So this is going to be, our best answer here is equiangular. But note, because all of the angles are acute, it also falls underneath the definition of an acute triangle. Once again, this is just like isosceles and equilateral. We want to give it the most specific and best name. So you're going to want to classify this one as equiangular unless you have something like this that says give two classifications for it. All right, part D. Once again, doing the same thing. So here we're looking at triangle ABD. So if I highlight it here, ABD. This one's going to be an obtuse triangle. And we know this because we have 100-degree angle right there. So we have at least one angle that's obtuse. All right, so now triangle ADC. That's this big one. And this one's going to be a right triangle. Once again, we're given that this is a right angle, so we know that it's going to have at least one right angle, so therefore it is a right triangle. And last but not least, we have BCD. All right, and this one's going to be an acute triangle. And we know this because we got a 40-degree angle here, so that's less than 90. Because of our knowledge of linear pairs and supplementary, if this angle is 100, then this angle has to be 180 minus 100. So that angle there is going to be 80 degrees. And then also we know that this angle right here is part of a 90-degree angle. We don't know how much, but we for sure know that it's less than 90. So therefore we have all three angles that are acute angles, so we have an acute triangle. All right, we're going to do the same thing, only now we're classifying it by its side lengths. So once again, see if you can do it all on your own. Pause the video and come back. So part A is going to be an isosceles triangle. And we know that's because we have two sides congruent due to our tick marks here. Part B is going to be scalene. We have no sides congruent. And part C, we're going to say is equilateral, is our best name for it. But it is technically also an isosceles because we have at least two sides congruent. And once again, as long as you answer equilateral there, you're going to be good, unless it says directions like give two names for it. All right, part D, our three-part part D. Go ahead and figure out what is triangle GIJ. We'll start with that one. And that's this whole one. And we know this one is going to be scalene. We have no sides congruent, or at least not enough information to tell us that. HIJ, triangle HIJ is right here. And this triangle is going to be an equilateral triangle. Because we have all three sides congruent. Once again, if you put isosceles on this one, and that's your only answer, that's going to be marked wrong. So you either want to put equilateral triangle or you want to put equilateral triangle and isosceles. So you don't just want to leave that as isosceles. And last one, GHJ. And this one is going to be an isosceles triangle. And this, because we know two sides are congruent, so therefore isosceles is going to be our best name for that one. All right, and just doing a little bit of algebra with these problems here. So we want to find the side lengths of the triangle. Now we're given a piece of crucial information here that's going to help us out. And that's, first of all, starting out with what AB is. And AB is going to be 15 units. But we're also given these tick marks here. And those tick marks tell us that those sides are congruent. So for AC is going to be X, but if we know they're congruent, we also know that X is going to equal 15 units as well. And then BC, since we now know what X is, we can plug it in, and we can say 15 plus 6 equals, well, that equals X, but then that's going to equal 21 right there. And I shouldn't put X there because X is already in the problem. So BC is going to be 21 units. All right, part B, getting a little bit tougher there, but we can do our equation. Also, just a comment, I apologize for the bad printing. There's nothing that the printer can do to salvage this one. That is a plus sign, that is a minus sign. These are a little bit easier to see over here, plus, plus, and minus. All right, so go ahead and write an equation for this one. Once again, we are trying to find all the side lengths of the triangle. And we can use our first one. We can figure this one out by using our knowledge of isosceles triangle. Those are congruent. So since they're congruent, we can set up the equation 3x minus 0.4 is equal to x plus 1.4. Once again, if you can't see the decimal or the symbols, I apologize for that one. Go ahead and solve that one on your own. When you come back, you will see it. All right, so for that first one, point B, we can set up that equation, and then solving for x, we're going to get x equals 0.9. And when I plug it in, 0.9 plus 1.4 is 2.3. 0.9 times 3 is 2.7, minus the 0.4 is 2.3, which once again, these numbers should be equal since those are congruent. So that kind of is a check to tell us we did the problem right. And then lastly, we just have to do 0.9 plus 0.1, and that just gives us an answer of 1 there. All right, part C. All right, so I'm going to kind of go through this one. Now, the nice thing about this one is that we can set up an equation for any of these. So we know that they're all equal to each other. So I'm going to set up, we'll just do the top half. So 2n plus 3 3/4. That's not really helpful to have a mixed number like that, so we want an improper fraction. So remember, to do that, we multiply the whole number times the denominator. 3 times 4 is 12, and then add the numerator. So that's 15/4 is equal to 7n. Once again, you could set it equal to the 10n minus 2 1/4 and do the same. Now, my first step, anytime I'm working with a fraction like that, is always to multiply by the denominator so we can cancel the fraction. So I'm going to multiply the whole thing by 4. So 4 times 2 is going to be 8n. 4 times 15, so those 4's just cancel, so we're left with 15. And then 4 times 7 is 28, so 28n. Subtract 8n from both sides. 15 is equal to 20n, and then divide by 20, and we get an answer of 3/4 is equal to n. Once again, our goal is here to find the sides. I'm going to plug this number into the easiest one, which would be 7n, so that I know that my answer for n, so if n equals 3/4, then 7n, I'm going to actually circle that one, is going to equal 7 times 3/4. 7 times 3 is 21, so that's going to equal 21/4. And as long as I know that for one of them, I know that's going to be the case for all of them. So they're all going to be 21/4, since that's an equilateral triangle. All right, so that is, once again, that should be hopefully a pretty easy lesson. The algebra probably just got a little bit tougher, especially working with the fractions in that last problem. But other than that, just classifying the sides and classifying the angles hopefully went all right for you.